All right, so last time we talked about relations, right? How numbers can be related, sometimes in functions and sometimes not functions, but relations. And we talked about several different ways to represent a relationship. And they can be input-output tables, they can be Venn diagrams, they can be ordered pairs, and then we even talked about graphing, how a graph is really just showing a relationship. And that's what we're going to talk about more about today. We've got, sorry about that, another way to represent mathematical relationships, and they're called time graphs. And that's what we're going to get into today, okay? Okay, so what are we talking about here? Well, you have to imagine we graphed the size of Mrs. Coin's balloon over time. Now, Mrs. Coin is a teacher in our early college department. So we have to imagine her blowing up a balloon, and she's going to blow it up to the point where it pops. Okay? Well, first and foremost, we have to label our axes, and we want to do this we want to show the relation between size and time. In time, we're going to put on the x-axis down here, the horizontal axis. Time is always moving. It's always going to be going. You can't stop time. You can't slow it down. You just have to deal with the fact that time is always moving. And we want to graph the relationship of time with size of the balloon. Or we had another class that wanted to do air, the amount of air in a balloon. But we'll do size, and we'll do this sort of generically. So bear with us. Okay? Now, parts of the graph. First of all, right here. If I were to put a dot right here, what would that represent? Well, hopefully you're thinking that would represent, well, time is 0, because that's at 0, 0, right? That's where that corner is. We don't have, this is really an XY axis. And we're not doing the negative side, because time can't be negative, and neither can the size of anything. So we're just showing half of the X and Y axis. So this corner does represent 0, 0, which means that time is 0, which means that we haven't even started. She hasn't started blowing the balloon yet. And the size would be 0, so the balloon has no size. Now, one might argue that the balloon has a size already, even before you start to blow it up. So would we want to start our graph right here at 0, 0? Maybe not. Maybe we would make it right here. I mean, it's definitely the smallest it's going to be. So we can plot a point there to show that the size, we haven't started blowing it up yet. Okay? Now, we're going to start the clock, and time is moving now, right? So she's going to inhale and then blow air into the balloon. So whether you choose, well, blow into the balloon, that means the size is going to increase as time is moving. So we're going to show time increase as time is moving with a slant, with a diagonal coming up. Okay? Size is getting bigger. Now, she's going to have to stop at some point and inhale in order to exhale again into the balloon. So that time it takes her to inhale, the size of the balloon is not changing. It's not getting any bigger, but time is still going. So we have to have a part of our graph that levels off here because the size is not getting any bigger. Okay? Then she exhales and blows up the balloon more. She inhales, and there's time that it takes where the balloon's not getting any bigger. And then she exhales. And then we're going to assume that she has the lung capacity of a sea mammal, which means that she's blowing a ton of air into the balloon every time. Otherwise, we can just keep doing this, a bunch more times. So when she inhales again, and then she exhales into the balloon, that's when the balloon popped. So what would that look like? What would the size of the balloon be once it popped? It would be nothing, right? So we would almost instantaneously drop this down to where the size is 0 instead of letting it crawl down gradually. Now, if it had a leak in it, then maybe we would want to make this a little bit more gradual and kind of come down this way. But we didn't. It popped. Boom. Size is done. And so that graph represents the size of the balloon over time. Okay, think you got it? Well, let's think about this. Sketch a graph that shows the height of the ball as a function of time. Now imagine I'm holding a ball at eye level. So I'm holding the ball up, and then I toss the ball up in the air. Okay? What would that look like? Well, first of all, our axes. Always label your axes. Time's going to be down here. Height of the ball is going to be here. Well, at time 0, so right here is time 0. At time 0, how high is the ball? Is it on the ground? No, I'm holding it at eye level. So I'm not going to start down here in the corner this time. I want to start up here, say. Now this doesn't have to be exact. We're just making rough sketches right now. So however far up you want to go to represent my height is fine. Then I'm going to throw the ball up. So the ball is going to go up. Okay? And then obviously at some point it's going to start coming back down. So now it's going to come back down and it's going to hit the ground. And then what's the ball do? Well, it bounces, right? So it's going to hit the ground. So the height's going to be 0, and then as time goes, it's going to bounce back up, hit the ground again, bounce back up, and then it's going to bounce up less and less every time until it stops bouncing. And so that would be the height of the ball. You got to think about what the height would be as time moves. And that would be it. Okay? All right, so more to look at. The length of a candle as it burns. So we've got time here. And we've got the length of the candle. Where's the graph going to start? You think again what this means. That means before time starts, the length is 0. Well, before we start to burn the candle, the length won't be 0. It'll be whatever the length of the candle is. Right? Then, when you light it, it's going to start burning down. And so the length's going to get shorter and shorter as time moves until eventually it burns out and it's gone. Okay? So that one being easy enough, it just kind of goes straight down. All right? Try this one. Think about this one. Stop the video, draw this out, and then start it back up and see if you're right, and change it if you need to. Okay, the water level in a toilet over time. What happens during toilet use? Okay? Well, before we even start time, right, where's the water level? Is it 0? Is there no water in the toilet bowl? No, there's some water, right? So we're going to start about right here. Again, it doesn't matter where. So the water level stays the same, and now someone uses the bathroom. So what happens? What happens to the water level? Well, without getting too graphic, depending on what they do in the toilet, the water level is probably going to increase a little bit. Then you flush it. Think about what happens when the toilet flushes. More water from the tank rushes into the bowl, so the water level actually goes up a little bit more. And then it goes down to pretty much 0, because that's where it flushes everything out. And then it comes back up to be back to its water level again. So it levels off because now the water level stays the same for however long it takes for someone else to use it. And then the same thing. They deposit their stuff, so the water level goes up, then they flush, comes back down, empties it, comes back up, back to the water level again. And so it will keep repeating this process, right, over and over. So we can stop there. All right? Makes sense? And then again, these are rough sketches. They don't have to be perfect. They don't have to look exactly like mine. As long as they make enough sense. You're showing that the water level goes down and comes back up to where it was before. And if you could show the water level rising just as it's flushed would be good too. Okay? Now, we are going to add a little bit of precision to them. We're going to add a story. I don't know if you noticed, but I kept telling a story even with the previous 4 graphs. But we're now going to tell a story. And based on the story, your graph should look a particular way. So, we start to read. You're thirsty, so you decide to get a drink of milk. You get a glass out of the cabinet and start to fill it with milk. Now, here's what I would do. I would underline or circle any phrase that you think is going to make your graph change. And so here's the first thing. You start to fill it with milk. When the cup is about halfway full, the phone rings, and so you stop to answer it. After a 3-minute call, you finish filling the glass. You take a few sips and then decide you want chocolate milk. So you stir in some chocolate syrup. That should change the milk. And then you gulp down the rest of the milk. So sketch a graph that shows how much milk is in your glass based on time. All right, so we're still going to do this where time is on the x-axis and the amount of milk is on this vertical axis. Okay? So what does it mean to be down here in the corner? That means time hasn't started yet and the amount of milk is 0, which makes sense because we're just getting a glass out to fill it up. So our graph is going to start down here. Then we fill it about halfway. Phone rings. So you stop pouring, answer the phone for 3 minutes. So for those 3 minutes, the amount of milk is not changing. And then you fill it the rest of the way up. Then you take a couple of sips, and if you want to, you can say, that takes a couple seconds to put the syrup down and stir it and all that kind of stuff. And then you take a couple of sips. So you're not going to drink it all. You take a couple of sips, it's just going to drop like so. And then you decide that you want chocolate milk, so you got to put syrup in it. Now remember, think about what happens to your cup of milk when you put syrup in it. That level rises a little bit, right? So we're going to go back up, actually, some. And once you're done with that, you're stirring it and everything, then you gulp it down. And so the amount of milk would go back to 0 once you're done. Okay? Now, this is more precise. If I'm grading this, I want to see that you're filling the milk the first time, so here. You stopped to answer the phone, so some time went by where the level didn't change. And then you filled it the rest of the way up. Then you took some sips. So this is another point here. If you didn't include the leveling off for putting down the milk or whatever, that's fine. Okay? But then you also have to have in here that you put chocolate syrup in it, the level went up, and then you gulped it down. So it's 1, 2, 3, 4, 5, 6 points that I'd be looking for to make sure you had in there. So make sure that every graph change is in there. Okay, if you do, then you're in good shape. Now, how about this story? Try this story. Read this story and start back up the video and see if you're right. All right, so what's your graph look like? So Mrs. Fife is going out with her friends. She leaves home and travels at a steady speed to Mrs. Hull's house. She stays at Mrs. Hull's house for 20 minutes and then drives to the mall. On her way, she gets stuck behind a street sweeper and slows to a crawl. So here's what we need to do. She, leaves her home and at a steady speed. She stays at Mrs. Hull's house for 20 minutes, and then she drives to the mall. On her way, she gets stuck behind a street sweeper and slows to a crawl. That's important. She finally arrives at the mall, shops for 60 minutes, and then goes home, apparently taking Mrs. Hull with her. Okay? So, distance from home based on time. So we're going to put time here, and then distance from home here. Okay? Well, before she even starts, she's going to be at home, so her distance from home would just be 0. So we're going to start here down here at the corner. She leaves home and travels at a steady speed to Mrs. Hull's house. So steady speed might look something like this. She's at Mrs. Hull's house. She stays there for about 20 minutes. Then she drives to the mall. Now, when she goes to the mall, she gets stuck behind a street sweeper and slows to a crawl. So maybe, I don't know, depends on how you look at this. Maybe she starts at a particular speed. But if she slows down to a crawl, it's going to take her longer to go as far. So your diagonal line here needs to really flatten out because it's going to take her longer to move a distance away. So it might really make this obviously flatter. Okay? She finally gets to the mall. She shops for 60 minutes, so flatten it out because she's still the same distance away from home. And then she goes back home. And so that would be her driving home because she's now back at home and at a distance from 0 from her home. Okay, but the important thing here that we haven't seen yet is to really show a slower speed as the line flattening out. Now, if she floored it and went at a faster speed to get to the mall, then you'd want to show a visibly steeper segment. Okay, so you want to make sure you got that in. Right? One more here. Try it. Stop the video, see what you get, and see how you did. All right, so pretty quickly here. You leave your house going 30 miles an hour to a friend's house. You get to your friend's house, have to wait because she's still putting on her makeup. After a few minutes, she's finished. You head to the theater. You're late, so you speed up. We got to show that. You finally get to the theater, watch the movie for 2 hours, drop your friend off at home, and then get to your house. So, distance from home based on time. Time here. Distance from home. Okay? Now, you're starting at home, so your distance is going to start at 0. So you go to your friend's house at a decent speed, whatever. You got to wait for 20 minutes because she's putting on her makeup. All right? Then you're late, so you speed, so your rate is faster. So you want to make this line a lot steeper, noticeably steeper. And then we're going to sit for 2 hours and watch a movie. Then we're going to drop your friend off. Now be nice and stop the car for a couple of seconds so that they can actually get out. Okay, and then go all the way back to your home. Don't go straight down to your home like your friend had to jump out of the car. Okay? Hang on, what happened here? Oh, messed it up. Sorry about that, guys. I messed it up. So anyway, time, distance from home. Oh, this is 5. Okay, sorry. Things got messed up here. Sorry. So anyway, 30 miles from home. You have to wait for 20 minutes or for a few minutes. Then you speed, so you want to show that. Watch the movie for 2 hours, then drop her off at home. So, sorry, I don't know if you got to see that. You could always back the video up, I suppose, to see it. But so you drive, get to your friend's house, wait a few minutes, and you got to speed, make this noticeably steeper. Watch the movie for 2 hours, drop her off, and then get home. And so your graph should look something like that. Okay? Now, we're going to turn this around a little bit and show you a graph and allow you to make up the story that goes with it. Now, it becomes kind of tough to force you into a particular story. Your story can have just about whatever you want in it. Okay? Your story has to explain each change in the graph. So, for example, this graph shows a plane's altitude during a flight from Denver to Las Vegas. Write a story to explain the graph. Now, start here, right? We always start at time 0. So what had to happen? Well, the plane took off. So you want to talk about the plane taking off. And then, for whatever reason, you can see that the plane's altitude stopped here for a second before it went up to where it wanted to just fly for a while. So you got to explain that. So what happened? You can have as much fun with this as you want. So the plane takes off. So plane takes off. To avoid a bird, the plane levels off for a few minutes. Okay. Then it climbs to its cruising altitude, right? You know, planes reach a cruising altitude where it just wants to fly. I don't know what that is. Usually 10,000 feet, maybe. All right. Anyway, so that takes care of climbing back up, and now it's cruising. Now, why did this plane dip twice? Well, most often people are thinking about turbulence. So the plane experiences turbulence. So it experiences some turbulence. And dips a couple of times. Okay? Then it flies through calmer air, right? Because then it sort of levels off again at its cruising altitude. After a few minutes, the plane descends and lands. Okay? And that would explain all of the different movements in the graph. Okay? Now, you have as much creative freedom here as you could possibly want. Your story can be about anything you want it to be about. Let's make it school appropriate, please. But you have to explain all the changes in the graph, right? Here's a graph that shows the water level in the tub as a function of time. Okay? I would encourage you to stop the video, write out a quick story, and I'll tell you what I think might have happened. Okay? So stop the video, write it out, and start it back up. Okay, so I'm not going to write it out. I'm going to save some time. So start down here. The tub's empty. You turn the water on and start filling it up. Then what happens? Well, the water level stopped increasing, so you forgot your bubbles for your bubble bath. So you turn the water off, and you go get the bubbles. Okay? So you turn the water back on and start filling it up so that the bubbles get nice and sudsy. That's why you stopped the water to begin with. Then you realize that you forgot your rubber ducky. You always take a bath with your rubber ducky. You're not sure where it is. So you turn the water off again to go look for your rubber ducky. Right? You find your rubber ducky, and so you want to jump in the bath. So you want to get in the bath. And so when you get in the bath, the level of the water rises sharply. Right? So that's when you're getting in the bath. Then you take your bath. Right? Then you get out. When you get out, the level's going to drop pretty quickly. And then you pull the plug in the drain, and the water all drains out. So something like that. I don't know. Something like that. I mean, your story could be whatever. And there could be other reasons for the water level leveling off and increasing. But you want to talk about why it's going up or going down a lot faster some places than others. Okay? And then you've got another thing here. What is happening in this graph We've got a time versus distance from home. Okay? What's going on in this graph? What's happening in this graph? How would you write your story? And again, you can come up with any story you want. But basically, now we keep talking about starting at your home and going away. Now you're already away from your home. That's why the graph starts up here. So why are you away from your home? Come up with a reason. Then you're going to start driving home, and for some reason you stopped. Come up with a reason why you stopped for a few minutes. Then you start heading home again, you stop again. Come up with a reason why you stopped. Because then after a few minutes you level off, and then you go all the way back home. Okay? And so your story can be whatever, and make it as funny as you want. The funnier the better. I enjoy reading those stories, but just make it school appropriate, huh? All right, that's it. Homework's out in Canvas. Get that done before next class.